Okay, we're trying to work out on this question the ratio of triangle AEC to triangle BCD. AEC is this one here, so I'm just going to draw this out. And the other one was, what was it? BCD. So that's this one up here. So B, C, D. Now we just need some areas here. So we need some length. We need this length here, BD, to be able to work out the area of this. So we need this length here, EA. So we need this distance along here. So we need to start getting some coordinates. So the first thing I notice is that we've got this function here. So we're going to start working out some values using that. So for instance, I know that the x coordinate here is 0. So I'm going to plug in x is 0 into that. Now if x is 0, that means all of this 8 must come from this y. So that's going to be 8. This one here, I know that y is 0 along the axis. So if y is 0, 2x must equal 8, and that means x is 4. So we've got this this journey here from A to O to B. So this length here is 4, and this length here, even though it doesn't look it, is 8. Right, we are told that the length of the ratio between AB and BC is 2 to 1. So everything on AB is halved to get from B to C. So do you see this where it goes 4, 8 here? To get from A to C, it's going to be half as much. So that distance there is going to be 2, and that one there is going to be 4. Again, it doesn't look like that. It looks like this should be longer than that. However, it doesn't allow us to work out a coordinate now. 0, 8 is, take away 2 is negative 2, and add 4, that's 12 there. Now, our other ratio that we have is that EC to CD is the ratio 1 to 2. So I'll do this in a different colour. E to C is that and that. So we know our ratio from E to C to C to D, it does look like it's going to be twice as big. This journey here is going to be twice as big as this journey here. So from here to here, we know that from here to here, we know that we have gone up from a y coordinate of 0, because we know that this has a y coordinate of 0, to a y coordinate of 12. So we know that that's going to be 12 there. So if this is going to be twice as big, then this is going to be 24, this distance here. So the y coordinate here was 12, so this one is going to be 36 up here. And we know the x coordinate is 0 though as well, so we can complete the coordinate. Now you can see that this line here has got a coordinate of negative 2, 12. We know this is the x coordinate is 0, so we know that this is 2. We know everything is twice as big on this one as it is on this one as it is on this one. So this has got to be a length 1. So we are 1. This distance here is going 1 left. So if this has got a coordinate of negative 2, this has got a coordinate of negative 3. So we've got coordinates of all of the points now. So we can start to work out some areas using our triangles above. So we wanted the length of EA. So let's have a look at this. We've got coordinate here of negative 3, 0, one here of 4, 0. So the difference between these is 7. So that is going to be 7. Now we need from the base here, from the axis up to the point C. So we just need the y coordinate of C. So the work I wanted to see was 12, so that is a height of 12. So the area is 7 times 12 divided by 2, which is 7 times 6, which is 42. Right, we need the length BD. We've got point B here at 0,8 and point D here at 0,36, so we've got 28 gap between those two. So that's 28. We just need this height here in between this line BD and the point C. So there's the line BD, there's the point C. We've got -2 distance there, so that distance there, as you can see in pink there, is 2. So that's 2. Area then is 28 times 2 divided by 2, which is just 28. So we've got our two areas there. So going over to here, we've got the ratio of AEC. Now AEC was the bigger one, so that was 42 to 28. Let's cancel this down, so that's 21 to 14. Divide both of them by 7, that is 3 to 2. So our answer finally is 3 to 2.